Hello everyone, welcome to my YouTube channel. Myself Gagan, currently pursuing a third year in Sri Venkateswara College of Engineering. Today we are going to discuss about the database management systems. Today we are going to discuss about the introduction to database management systems, introduction to the ER diagrams, introduction to the relational algebra. First we are going to discuss about the introduction to the database management system. So what is database management system? The database management system is a software tool used to manage and organize the data. It provides an interface for the user to interact with the database and performs the operations such as storing, retrieving, and updating the data. Next, we are going to discuss about the advantages of using a database management systems. Data consistency. Using database management systems ensures that the data is consistent and accurate across a multiple application and the user. Data security. Database management provides a robust security features to protect sensitive data from unauthorized access and ensure the data privacy. Improved data sharing and accessibility. A database management enables a easy sharing and access to the data among the multiple users and improving the collaboration and decision making process. And next we will discuss about the types of database models. Database management utilizes different types of database models to organize the structured data. Each model has its own unique way of organizing and representing the data. The four main types of database models are relation model organizes the data into tables with the rows and columns. Data is stored in a structured manner and relationships between the tables are established using keys. Hierarchical model organizes the data in a tree-like structure with a parent-child relationships. Data is stored in a top-down approach where each parent can have a multiple children but each child can have only one parent. Network model similar to hierarchical model but allows for more flexible relationship between the data elements and data is organized in the graph-like structures where each record can have a multiple parent and child records. Object-oriented model. Storage data are objects which can have attributes and methods. Data is organized based upon the object-oriented paradigm, allowing the complex data structure and relationships. And next we will discuss about the data manipulation and querying. Data manipulation. Data manipulation involves the inserting, updating, and deleting a data in a database. Querying involves the retrieving the data from the database based upon a specific criteria. Data security and integrity. Protecting the data. Database security involves the implementing measures to protect the data from unauthorized access, ensuring the data confidentiality and privacy, ensuring the data accuracy and reliability. Data integrity mainly focuses on maintaining the accuracy and reliability of data and preventing the data corruption or losses. And next we will discuss about the introduction to the ER diagram. So what is ER diagram? An ER diagram or an entity relationship diagram is a visual representation of relationship between entities in a database. It helps to design and understand the structure of database management. Next, we will discuss about the components of an ER diagram. Entities, attributes, and relationship. Entities represents the real-world objects or concepts that can be relevant of the system being a modeled. Attributes define the properties or characteristics of an entity. So they describe the data can be associated with an entity. Relationships can define the connection or association between the entities. So they represent how the entities are related or interact with each other. Next, we will discuss about the entity types and attributes. Entity types. Entity types are the categories of an entities in an ER diagram. So they represent the different types of objects or concepts that can exist in a system being modeled. Attributes. Attributes define the characteristics or properties of an entity types, and they describe the specific details or information that can be associated with an each entity type. Next, we will discuss about the relationships and cardinality. Relationship describes the connection between the entities of an ER diagram. Cardinality defines the number of instances of one entity that can be associated with the another entity. Next, we will discuss about how can we create an ER diagram. Identifying the entities and attributes and relationships. Creating an ER diagram involves identifying the entities, attributes, and relationships within the system or a database. Mapping to a visual representation. Once the entities and attributes and relationship are identified, so they can be mapped to a visual representation using a standard symbols and notations. This helps to visualize and represent the structure organization of the system or database. Iterative process. Creating a ER diagram is an iterative process that requires a careful analysis and design. So it may involve the multiple iterations to refine and improve the diagram based upon the feedback and changes in the requirements. Next, we are going to discuss about the database security and integrity. Processing data. Database security involves implementing measures to protect data from unauthorized access and ensuring the data confidentiality and privacy. Ensuring the data accuracy and reliability. Data integrity focus on maintaining the accuracy and reliability of data and preventing the data corruption or losses. Next, we want to discuss about our last topic, that is introduction to relational algebra. So relational algebra is a procedural query language used to query the database to retrieve the actual result on a some condition. It enables the user to work with the database at a conceptual level. In relational algebra, there are several operations. The first one is selection operation. Selecting a specific data. The selection operation retrieves the tuples from the relation that can satisfy the given conditions. So it is likely applying a filter on a database on a certain criteria. Condition based filtering. This operation allows the for retrieval of data that meets the specific criteria based upon the condition defined by comparison operators. Subset of data. In returns as a subset of relation that satisfies a specified predicate, and only the rows that match the condition are selected. For an example, selecting an employees with a salary is greater than 50,000 from the employee database. And next operation is projection operation. Extracting columns. The projection operation is select a subset of attributes from the relation and resulting the new relation with only specified columns. Column based filtering. This operation allows the retrieval of specific attributes from the relation, discarding the unnecessary fields and focusing on the relevant data. For an example, projecting only the name and age columns from the student database to create a new relation. And next we will discuss about the third operation, that is union operation, combining the data. The union operation merges the two relation into a single relation and eliminating the duplicate tuples to maintain the consistency. Data consistency. It ensures that the resulting relation contains all rows from both input relation while removing any duplicate rows. For an example, combining the results of two select operations to create a union of employee from two different departments. Next, we will discuss about a difference operation. Set subtraction. The difference operation retrieves the tuples from a one relation that do not appear in the second relation. Unique elements. It produces a result that contains tuples and that are unique to the first relation, excluding any rows that are common in both relations. Visualizing contrast. The operationally visualize represent the distinction and exclusivity between the two sets of data highlighting the difference between the relation. For an example, finding the employee in one department who are not present in other department using difference operation. Next, we will discuss about the Cartesian product operation. Size of an Cartesian product. The result contains the number of rows equal to the multiplication of number of rows in input relation combined data. It returns the combined set of all possible pairs of tuples from input relation and resulting a new relation. For an example, student table with a course table to show the possible combination of student and courses. Next, we will discuss about the join operation, combining attributes. The join operation combines the columns from two relations to construct a result relation based upon a related condition. Data integration. It integrates the data from a multiple relation into a single table, linking a related information from the input relations. For example, joining the employee tables with the department table to employee details with their respective departments. Next, we will discuss about the division operation, mutual exclusivity. The division operation retrieves the tuples from one relation that can not related in the second relation. Distribute result. It produces a result that can consist of tuples that are uniquely identified in the first relation but not in second relation. Data separation. This operation separates the data based upon a certain criteria, creating a distinct data subset from an input relation. Example, for instance, finding the students who have enrolled in available courses from student and courses database tables uses division operation. Next, we will discuss about the last operation, that is rename operation. Name modification. The rename operation allows us the modification of the attribute name of the relation, providing alternative or update identifiers. Attribute as reassignment. This operation facilitates the reassignments of the field names and allowing for an improved clarity and consistency of data representation. Efficiency. Database management process enhancing the operational efficiency and data accessibility. Security. To boost security, measures in the database management systems ensures the protection of valuable data against unauthorized access. Scalability. Database management can adapt and involving the data demands and organizing the requirements and ensuring the scalability. Thank you guys for watching this video. Please like, share and subscribe. See you soon in the next video.